Mogwai, graph databases for your app. My name is Cody Lee. Disclaimer, I work for a company called Wellaware. We're kind of an oil and gas company, and I'll explain a little more on that. If you want to follow along, go ahead and clone that repository. It works really, really well on Mac and Linux. Not so sure about Windows. I don't really spend the majority of my day in Windows. So I'll give you guys just a second. It'll be on the next page too. Why isn't it? Oh, here we go. All right. So, who am I? Technical co-founder of Wellaware. Right now, I'm mostly a developer. My title is so misleading, I'm not even going to put it on there. It's one of those things that as we grow, things need to change. Good question. Oops. All right. So, also the conference chairman of Texas Linux Festival. I don't know if anybody of you guys have heard of that, been over there. I think I've seen a couple of your faces over there a few times. It's an open source conference and mostly held in Austin, Texas. It'll be again, hopefully this time in April. Pending venue contract. We're in the process of that right now. So also open source contributor, maintainer of the RexPro Python library. That's the library that Mogwai uses to connect to graph databases. And then that's the actual binary protocol instead of the HTTP REST protocol. Also class of 2010 mechanical engineering. I know a mechanical engineer doing code, what the hell? It's true. And an active paintball enthusiast, that guy over there will tell you. So what is Wellaware? Wellaware is an oil and gas software as a service, networks as a service, platform as a service, data as a service, whatever you want to call it. The whole point is to offer an end-to-end solution for the oil and gas providers to get data out of the field, do something with it, and add value to that data. That is essentially what Wellaware is. So we do have our own proprietary network. You'll see that RPMA over there. Same guys out of Qualcomm that did CDMA, they flipped it on its head. So instead of a little amount of users, lots of data, it's lots of users, a little amount of data. Except for it's not users, it's machines. So they tend to speak a little less frequently than people. So we're also hiring, wellaware.workable.com. I've talked to a few of you, but if you're interested, you can see what jobs we have posting. There's more than that, and that's posted there, so if you have an inquiry, then just come see me or Aaron in the blue shirt over there. So, Mogwai. Again, here's the repo. Clone it if you want to. There is a setup script in there, but make sure to read the README first. It does kind of expect you to have RexPro Python already installed before that setup happens, because it tries to load the data. And if you want to follow on, I suggest you do it now, because the database is going to load. It's going to take a while. I mean, it takes like 15 minutes on my machine alone. So what I'm going to do, I'm going to go over a quick what graph databases are. And then I'm going to talk about what Gremlin is. Then I'll finally get into Mogwai. So once you have the kind of basics understanding of what graph is, how do you work with graph databases, then I can talk about, okay, what is Mogwai? What is its purpose? And then I'll have a little example showing an actual application built using Mogwai. So this is not my goal. I don't want to scare the crap out of you. So if you feel totally scared and really confused, tell me. So what are graph databases? They're basically a NoSQL type document store. There are different variations of graph databases. The ones that I'm going to talk about are property graphs. And basically each vertice or node, if you were in Jeremy's talk, it contains a document basically. Also an edge is also a document. The common synonym is you'll equate vertices with nouns, person, place, or thing, and an edge is a verb. So it owns something. It can follow somebody. It is friends with somebody. I lost control. So, graph database short list. There's tons of them out there. Lego Graph, Big Data, Dex, which is now Sparksy. Infinite Graph, Neo4j, which is probably the one you've heard of. ThingWorks uses Neo4j. A few other companies use Neo4j. OrientDB is another popular one that's kind of coming up. And then Titan. I'm going to focus most of my talks on Titan. Mogwai was built for Titan. The reason for that was Titan, as opposed to say Neo4j, was built for scale first, using Cassandra or Hadoop as a backend, whereas Neo4j was kind of designed around a single machine, single cluster. And if you want to scale that, good luck. it gets kind of weird. So again, Titan, designed for scale, supports ACID transactions using Cassandra or Hadoop. You'll have eventual consistency with those depending on your tuning parameters. So that's all, go find your database engineer and tell them to tune it. Because if you don't have it tuned right, then you get some wonky results. But that's true of any database. It does support Exanch full text searching through Elasticsearch or Lucene. And its main method of interface is Gremlin. So it's all written in Java. You can deploy it anywhere on Windows, Mac, Linux, wherever you want to do it. And when you use Gremlin, you're actually in a Groovy shell. So you have Groovy code that you can use the Gremlin syntax for. And Gremlin's just a DSL. There's also the API they made available, and that's called Rexter. The name's changing as things are changing. But Rexter is basically allows you to do a RESTful interface to Gremlin. So you don't have to write Groovy code. You can just inject it from whatever client you have. So whether that be whatever programming language you have, if you have a HTTP library, then you can use GraphDB. So, basic Gremlin refresher. I touched on Gremlin. Gremlin's a little weird. It's a DSL, so we won't go too far into it, but some basic refresher. So, it is a graph traversal language. And I said it's a DSL. It was originally designed for property graphs. You can use it in other examples. But you can execute complex queries and basically make your graph do the work for you. So instead of a relational database, which is idiomatically not relational, when you look at a relational database, if you have no idea what the context of the app is doing, how are you going to know what links to each other? You're not. You're going to go, hopefully that the table row, the column ID matches to some other table name, and then that hopefully matches to the right, the primary ID of that table. Well, if it doesn't, then good luck. Whereas in graphs, you basically have all your schema is inherent. So even how the application glue is connected, your nodes are connected to the schema that's associated to them. And not always the case. You can build some other application glue around that. What Gremlin does is it allows you to put your glue in your code and make the database return the structure that you want. So instead of having to query this table and do a table join across these 4 other tables, and then you're left with this huge table that you just wanted a dict for, you can return a dict from your database directly. Mind blown yet? Okay, so this simple example, what I'm going to do is, say I have a vertice that has a type of person. So this vertice represents people. And I want to find the people that are over 30. That's all it takes. You can do the same thing in SQL, right? So select from people with age greater than 30. Same kind of syntax. This one's a very simple case that translates very, very similarly to SQL. So how do you find friends of friends? So Twitter, how many friends of friends do you have? Well, this is actually really simple. If all your friends or all your people are connected, you know what the person's unique ID is, you find out who they're friends with, and then you loop it a few times. And you can make a path that says, okay, I'm Cody, I'm friends with Aaron, and Aaron's is friends with Kyle. I'm Cody, I'm friends with Aaron, but he's also friends with Jeremy. I can do this over and over again, and it's very, very simple. Someday I'll learn IPython Notebook. I'm actually a noob at this. So Gremlin, we'll pop in the Gremlin Shell real quick, and I'll show you real quick. Let's come over here. There we go. So we popped into Gremlin. Let me blow this terminal up so you guys can see this. I have never actually changed the size of this, so this will be interesting. Is that big enough? Okay. So I've loaded some data in here, and what I'm going to do is I've loaded basically a movie database in here. And so what I'm going to do is I'm going to open the graph. So this property file tells how Gremlin to connect to the graph if you're in the Gremlin function. So load up the graph, connect to it real quick. So right now I'm connected, and it's connected to localhost. You know, you could imagine this being connected anywhere. So my graph object is G. So that actually represents the total graph space, the whole graph world. And so if I did a count on how many vertices are there, I think there's roughly 9,000. I could do like this. This will take a while. Not really, but there's 9,000 vertices in here. I believe there's roughly over a million edges. Give it a second. Okay, a couple seconds. This is why you index people. And I might need to cancel. There we go. Okay, so roughly 1 million, a little over a million edges. So this is movies and users and how they rated those movies and what other genre those movies are rated to, what their occupation is. Basically like a scoring system for movies you've seen. So similar to IMDb without the content. We'll think of it like that. So let's say I pick up this movie that I really care about, and I just happen to know the primary ID of it. So this is this movie right here. This movie is Toy Story. This movie ID you see right here, this was from the movie database library, so this is the record that they used in their CSV output, so don't worry about that. But it is a type of movie. And so if I look at the movie, and I want to see, well, what's going out of this movie? Well, there's 3 vertices here, so what are they? Okay, well, they're genres. That makes sense, right? Movies have a genre, and they can have multiple genres if they kind of coexist and kind of overlap. So Toy Story is an animation, it's a children's, and it's a comedy. That makes pretty sense. What's pointing into this guy? Lots and lots of people. All these people represent people that have rated Toy Story. So 2,000 people have rated Toy Story. So that's kind of useful information. Instantly you can tell that movies have genres, people rate movies, and you can even figure out what edges those were. So oh yeah, there's a 1-year-old in there. So the label for that edge, right? So what was connecting the two was this edge, and it has a label of rated. So rated has stars. So if I look at all the stars, you'll see 4s and 5s and 3s and probably a couple 2s and 1s for some old cranky folks that didn't like Toy Story. So that is the Gremlin expression, and that's a very, very simple introduction. Did I kill anybody's mind yet? No, good, okay. Then we can move on with life. So that's great and dandy. If you're a Java developer, great, this works really, really well. If you're not a Java developer, which I assume some of you aren't because you're at Pi Texas, we'll move back on. Oops. All right, so here comes Mogwai. Mogwai to the rescue. So you love dicks, right? Kind of suck, right? If you use Mongo, then you have to do a lot of application glue to figure out what relates to what. And then you're left with this whole application glue that can be done 17 times in your whole application code base, and different ways too. So Mogwai is kind of a very opinionated library. The underlying RexPro Python interface is very unopinionated. It's just a transport protocol means. So it'll provide back the raw dicks that come back and forth. But Mogwai uses RexPro Python. So it is known to work with Titan 4X series and the Titan 5X series. There is plans when Titan 9X, 0.9X comes out, and when the 1.0 release comes out. Titan in itself is still under heavy development, although we're using it in production systems, and for the 4X series, it's actually very, very stable as it is. I can go into the nuances between the two, but right now, Mogwai, or Titan 0.5X supports the concepts of vertex labeling, so actually a built-in inherent mechanism. The element type that you saw there earlier was something that Mogwai adds. Vertex labels exist now, much like edge labels do, which is a built-in type for Titan. Although the RexPro protocol doesn't push that across, so that's why Mogwai doesn't currently support it. When Tinkerpop 3 comes out, the current Titan releases use Tinkerpop 2. It's a whole development stack on how graph databases work and communicate with each other, and how you use Gremlin and all that stuff. That right now uses RexPro and the REST interface. When Tinkerpop 3 comes out, they're going to support the notion of WebSockets. And a WebSocket's a WebSocket, but what's really cool that opens up, it allows streaming results. So instead of getting a huge dump of data, and let's say there's a million points that I want to do, I can now stream results and just yield them as a generator. So that doesn't blow your mind yet. That's going to be really cool. So those are the two locations for the little the read the docs. Read the docs, and if anybody wants to improve the docs or catches some errors, which there have been several people that have caught errors, please notify me. Email, post it on the issue on the Bitbucket, or go to the, I need to post a link to this, but to the mailing list. So Mogwai is Apache 2, so you can use it anywhere. You don't have to link back. I mean, I really don't care if you link back. It's nice to know when someone's using it because it's kind of cool just to figure out. But you can use it in commercial products. We're using it in our commercial product. Vertex and edge support, again, property graphs, use it however you want. There is query support, and I'll show you a really cool example using Gremlin Pi. It's another library that someone else has written. Kind of gives you the global graph query. I haven't implemented that in Mogwai yet. Because mostly the queries around vertex-centric queries, and so you can actually do indexes on a single node, if that makes any sense. So you have really optimized indexing across a node. So if that's that simple example right there, when I looked up that movie, I didn't have to go through the whole tree of users and their ratings. So don't think of it as a separate table. There was actually an index right on that node. And so basically, I can really quickly just isolate what I care about and then move on with life. Connection pooling support is built in. If you use Mogwai out of the box, and you're going to get the default synchronous connection pooling. So everything's synchronous, user beware. There is concurrency support with gEvent eventlet. If you want to add like async IO and somebody wants to do it, go for it. I welcome the contribution. We don't use those at WellAware, so I have really not a lot of motivation to do it because they kind of go. It is tested for Python 2.7, 3.3, and 3.4 on a regular basis using talks. You can find the build status using Workable. What am I doing on time? Oh, good. Supports custom Gremlin scripts. So that's the key feature right there. So how many of you guys have heard of or used bulbs? James Thornton did that. So one of the key features there is using your own custom Gremlin scripts. So normally, if you're using external language like C# or basically not Java or Mogwai, right? You would have to basically load all your custom commands, all your Groovy scripts as basically entities within your Rexter deployment. So you have to basically make your own DSL in a sense. And then you can statically load those so other languages can use them. It's a real giant pain in the bus, and there's a huge disconnect. So Mogwai, as well as bulbs, allows you to connect your actual application code with the actual queries that you want and put it in the same application code. So even though you're keeping your application code there, there's pros and cons to benefits, right? So you can make a DSL and keep it in your own DSL containerized, and the database guy can optimize the crap out of that function. Or you can put in application code where needed and then run that and send that over the pipe, run that command, and then have the results returned. You can iterate very quickly on that as well. So again here, when I said also supports custom DSL integrations, Mogwai will allow you to do imports. So you can actually import whatever class structure is available within the context of that JVM. It does have built-in performance monitoring. We use PyFormance for that. So everything actually is monitored right off the bat. It just goes nowhere right now if you don't enable it. It'll just basically dump to dev null, and that's it. So you can monitor things like how many times was a call used on average, how many times is it used in your whole application, the number of calls, well, I've already said that, the time it takes, the mean time it takes, all those kind of things. You can integrate back in. So those of you that are very interested in application performance, that's very, very useful, and it's very, very lightweight to use. And so you can extend the crap out of that. I built an extension for New Relic, for Graphite, all these different logging tools that you can use as well. Do support save strategies. So this is a legitimate, in a sense, database library. So it's an object graph mapper, right? So you expect that if I can set a date time, I expect it to be a date time, right? And if it's not a naive date time, which by the default date time is a location-aware date time, it expects that. So it's going to enforce that. It's also going to expect if you have a save strategy. So only update for a case of an integer, right? If it goes up, you can export that. Don't save it if it doesn't change. So you're going to save a little bit of time there, and you can tune these to however your application needs. And there is factory board. So if you guys have used factory board, it's a really easy way to create models, do tests if you have defaults that you want to use. And there's actually an example in the docs. So let's get started. So how many are still waiting for their data to load? Hopefully no one. Yeah, it's going to take a while. But what version of Python 3 are you using? Shouldn't be. Talk said there wasn't a problem. Okay. I'll sync up with you after this, and maybe we can figure it out. So the basics. So how are you going to connect to your database, how are you going to molly over these edges, and how are you going to do your CRUD operations. So this is where things get fun. All you do is you import Mogwai connection setup. And it's as simple as that. You set up and you tell it what graph name you're connecting to. So you can actually separate your graphs. So it supports multiple graphs. The only problem is right now, if you call setup, that's the context that the whole app is in. So the whole Python GIL, that's the graph you're using. So if you call it multiple times, it's just going to change graphs. So be careful. One of the things that would be nice would be to change it on the fly. So modeling a vertex and an edge as a model. So go back to Django days. Remember, you had a class structure that defined what a person was, that defined what your trinket might be. Same concept. So I'm going to import my vertex and edge base class, and I'm going to import string and integer properties. So what I'm doing is I'm creating my little custom vertex. The actual element type that's stored, so remember that little element type that we had? Well, I deleted it, so you won't see it. Basically is my vertex. So this name is going to be my, without the underscore vertex, underscore name. That's the default implementation that Mogwai does. So if you go to the Gremlin REPL and you're like, why isn't name there? Well, think about this. If you had a person with the property called name, and you had a trinket with a property called name, and you had this other object with a property called name, if you do an index on name, that's a terrible idea, because now you're getting all this crap that you don't really care about. And so it kind of, Mogwai does this default implementation where it prefixes the property name with this string right here, minus the underscore. And so that'll make it easier for you to do indexing, and then you'll get much more performant results. It was done by design so you wouldn't shoot yourself in the foot. So I define the name property. It is a string. I can set a max value on here if I want to. All the typical things that you normally expect. And a test value, so I'm just going to do a default incrementer on a global counter. And then the same thing with my edge. So my edge is going to connect to vertices. So my vertex is always going to connect through my edge to another my vertex. So nothing happened. There's no output. You don't expect any output. So what I'm going to do is, okay, I'm going to create my vertex. I'm going to create another one, and I'm going to connect them. Very, very simple. My vertex create. If you simply load my vertex without the dot create, it's going to load it in memory, but it's not saved. So you still have to save it. So you can still do operations where you create in-memory representations of them and how they connect, but you don't have to save them, so you don't have to persist them to the database. That's one kind of cheating thing to do. But it doesn't work so hot with the edges. It can work. I just don't recommend it. So similar to the GraphX talk where everything's in memory, you can do it, but as soon as you try to query the database, nothing's going to be there and it's going to throw an exception. So I'm going to create a my vertex, create the two, link the two, and then I'm going to show what happens here. So this is the representation of my vertex. It is in the database. This is Titan's unique ID that it gave it. So you could query this ID using g.v and then this really long. And you can see the values that are associated with this. And then the edge, what values are associated to it as well. So this edge, you notice, has a GUID. And that was done by design for Titan. So that's the native implementation of Titan. So if your Blueprints enabled graph uses some of the schema, Mogwai doesn't care. As far as it's concerned, it's basically a string. So I want to figure out, okay, how many vertices do I have? How many edges do I have? The one catch about edges, it's really not recommended to do edge.e. Really not recommended. So this was also by design. It actually makes you force type out the edges that you care about. I just don't recommend doing it. You could overload the function and do whatever you feel like at that point. So in the sandbox environment, I have 4 vertices because I ran this right before, so my bad. And you can see what the vertices are. When I query for vertices, I always get back a list. Mogwai is very good about returning lists. So you almost in all cases except for this very special function, you will always get a list. So you can always iterate on it. And that'll segue nicely into the WebSocket world where everything is a generator. So then you're always iterating on stuff to begin with. And if your app's written, hopefully for scale, then it should always yield results. So again, there's my edges, and we can move on. So now that I have my edge, okay, I'm going to print out the IDs. You've already seen these. I'm going to query the inward-facing vertex for that edge using, from that vertex, vertex 1, to using my edge. So I expect to get my vertex 2. And then the outward-facing vertex, I expect to get nothing. I'm sorry. The outward-facing vertex, I expect to get vertex 2. And the inward-facing vertex, I expect to get nothing. Whereas the opposite is true. On the outward vertex from vertex 2, I expect to get nothing. But the inward-facing one, I expect to get vertex 1. And so here's a little check right here as well. And that is right here. So you see, you get nothing, which you'd expect from the inward-facing vertex call. You get a list of my vertex, which is just my vertex 1, from the outward-facing vertex. And when you compare the two, you do in fact get the same thing. Sanity has been restored. You're not losing yourself. Same can be done from the opposite side, from my vertex 2, as you saw before. And then we can do a couple other fancy things, like get what's between my vertex 1 and my vertex 2. So what edges exist between that? For the case where you might have like, oh, he's friends with, also he teaches that person. So let's say a professor teaches a student, they just happen to be friends with him from a past life. So you can have multiple edges between that. So if you want to find out what edges are between that, you can query those edges, and you would get my edge. So that's the only one that exists right now. And if I want to delete them, it's really simple. They're gone forever and ever. So if I were to rerun this, you would expect that to throw an exception because they don't exist. All right, so let's get a little fancy. That was the basics of it. We're gonna go through some custom Groovy examples. There's a special relationship object or method that you can use. I'll show you how to serialize examples using Pickle, and then dealing with the non-model properties. So let's say your app only cares about name, but the person might have an email field, they might have a phone number field, but you really don't care about them. But you don't want it to interfere with your app if you make a change to their name. There are some valid use cases for that. So the whole concept wasn't to force you to use it, but you could still use it just like you would a document store if you really cared about it. And then we'll go into concurrency. Concurrency is probably the easiest one to use because you just use it in the setup function and that's it. So again, I'm going to create a new model. I've loaded this custom Gremlin Groovy, and I'm going to show you that. So all I'm doing is my friends of friends Groovy code right here. So it's the same code you saw before. I'm going to iterate it through 2 times, and I'm going to return the path. So I'd expect the originating source, the person that I care about, the friend that they know directly, and then their friend that they know. So that's the friends through friends. So it's going to send this over the bus, and it's going to return it. So I've defined what a person is, how to get that Gremlin path And this is, normally you don't have to do this, you can type it in or look in the local directory, but because the IPython notebook is interactive, you have to use this custom fancy stuff. And then here's my edge, so they're friends with and since. I just picked today just because. You could use a partial function here if you wanted to, so it automatically generate the ID. So defaults they do accept callable functions. Come on. I'm going to get this one day, I swear. So I'm going to create Bob, I'm going to create Alice, I'm going to create Tim and Susan, link them together, and Bob's friends directly are Alice. Bob only has one direct friend. It's kind of lonely. Sorry about that, Bob. So who is Bob's friends of friends? Okay, well, if you look at it, Bob is directly friends with Alice, Alice is friends with John, and Alice is friends with Tim. And Tim is friends with Susan, so if I look through friends of friends of friends, you'd eventually get to Susan. I don't really care about that. I just want to know Bob's friends of friends. So somewhat relational friends that he'd probably meet somewhere in a bar, hopefully. So if we look at it, I get, okay, I have a list of lists. So I get triples here. I get Bob, I get Alice, and John. So there's a direct relationship. Bob knows Alice, and Alice knows John. That's how Bob knows John, sort of. Bob knows Alice, and Alice knows Tim. So Bob kind of knows Tim, hopefully. So that's using custom Gremlin. That was wicked easy. And as long as you know Groovy, and as long as you understand the Gremlin, then everything kind of makes sense. So I'm going to go ahead and delete those guys. They live the short life. And we're going to move on to relationships. So relationships, the concept of relationship is to shortcut these direct methods that you care about. Basically, if I want to know a subject being a person, or an entity like a company, might own a few trinkets, right? And so I want to basically find out who owns those trinkets, but I don't want to type out the Groovy code for that. I really don't care. I don't want to type out, okay, out E or out V using trinket. I just want to make this really, really simple, developer-friendly, own trinkets. So this is what this does. It's basically a shortcut to out V with owned objects of type trinket. So if you use this function, as it is, you can say, okay, well, I created a trinket a clock. Bob owns a clock. You got that? And so, okay, if I do the normal traversal, what vertices are out that have owns object? I would expect to get this trinket. If I do the same thing using own trinkets, and I specify that I'm looking for the vertices, not the edges, then I'm going to expect to get the same thing. And you'll find that I do. So this is a really easy method of getting direct relationships out the door really quickly. Serialization. So how many of you guys use Celery or some bus transport? Cool, 1, 2, 3. The whole idea for Celery, we're using it now, we're kind of moving away from it. There's some other reasons for that. Is you can pass an object around and expect to have the full object instantiated, and you can actually use the methods on the call. And so before, you couldn't serialize anything with Mogwai until like 0.4 release, but now I support it. And so you can use Pickle. You're welcome to use JSON, by the way. JSON is actually what's sent over the RexPro protocol. So if you wanted to serialize it, then I'd suggest you just serialize it the same way that the RexPro protocol does it. And I'll get into that, and I'll put a documentation page up there, I promise. It's really easy. But basically, I want to dump the string that Bob is. And, oh, did I delete Bob? I think I did. It's okay. I'm going to serialize the trinket and serialize the edge. I'm going to show you that they actually are serialized as a Pickle object. And this works for Pickle and CPickle, by the way. And then I'm going to deserialize them. And I expect to get Bob deserialized should match Bob, minus the memory location. But all I care is are they the same? So you'll see that, yes, in fact, Bob being serialized has been serialized in that these assertions did not raise a warning or an error. Very, very simple. So again, easy to adopt other serialization methods, JSON, if you want to do XML. It's fairly straightforward. You can define your own ins and outs. The main method here, which is not shown, is there's this special Mogwai models element, and that's the base model for a vertex and an edge, since they're both element types. There's a deserialized function, and if you overload that, then you can change how Mogwai works internally. And that's the really, really special magic function that users beware, don't kill yourself. Oh, I still got some time. So dealing with the unknown. So vertex edge is a document. Who all is writing to that document? You don't always know, especially if you're in a large enterprise location. Some people may have different schema that they need, or they're going to add something that you didn't have in your app, but you don't want your app to break just because someone adds a freaking field to a model on your document. Or let's say you have this concept like ThingWorks, where you can define your own structure. You can do that here too rather easily, and so it allows you to do these dynamic things really, really very easily, but still makes sense in Graph. So again, you can use it like a document, and the default save strategy for these is always save, so be careful. So every single time that someone changes at least one thing and you go and save, it's going to send all the values. So there's 100 values in there, it's going to send all 100. Doesn't matter if they change or not. So here again, I have a trinket that you saw earlier. It had a clock. I'm going to add the engraving clock, and you'll see that here. And when I add that, I now have this engraving. So this is the items. So you have to actually use items. So treat it like a dict. You can actually do delete operations on it. That'll actually delete it, and you resave it, and then you notice it's gone. When you do a save, it actually does persist it to the database. And then you just walk through it again. Sorry, going through these really quickly. But basically the whole concept is here. This, you can do a get and fail fast, fail hard, do whatever you would with a normal document database, just like Mongo, if anybody used PyMongo. Concurrency, all right. So there is eventlet and geventlet support. The synchronous is used by default. I recommend you use that in development mode because you will not shoot yourself in the foot and it's really easy to follow. Unless you're doing performance testing, then don't use it. Again, if you want to do some additional concurrency support, the best place to do that right now is in the RexPro Python library, because that's actually where all concurrency is. Mogwai itself is actually a linear application, so all the I/O blocking operations are in the actual protocol. So it's fairly fast itself. So this it's very, very simple, right? So you import your setup function and you just specify what kind of concurrency you want. The default is this bottom one here, synchronous. So here's the fun part. Graph movie database. There's a cool transition that's going to happen here as soon as I find the window. So again, this is a movie database. I loaded it up from, I can't remember what site, but it's available. Basically, I created a little bottle app, and I'm using Mogwai. And so what I've done is I've loaded all 1 million vertices, all 9,000 vertices, 1 million edges. There's a total of 3,000 or almost 4,000 movies and 6,000 users, which are consisted of 21 different occupations, at least in this data dump that you're probably loading. And so basically, I'm trying to replicate IMDb with all of the fancy stuff, so let's keep it simple. So again, if you're following from home, if you load this IPython notebook, you can follow this as well. So if I want to find out what's the average mean age for all the users, it's really simple. There's actually a custom Gremlin function in here that I'll pop over here. Oh, I forgot to name my debugging. So user mean age, right? So I'm going to count all the users, and I'm going to use a user age function, and I'm just going to do a mean.
We can't read that.
Does anybody know how to make that bigger? Let's see here. Well, let me just open it up in Vim, since this is already massive. All right, can you see that? Okay. So, user mean age. I query all the user elements. I take their user age property. So this is a Java pipe, so it doesn't iterate until it needs to. And then I take the mean. And so literally it goes through each one, adds it to a giant sum, and then takes the mean. You'll see this other one that I'll use, the occupation distribution. So I would pass in occupation type, and then I would check out, okay, well, I'd check all the users, right? I'd check out who has an occupation. I'd group count those based on occupation. And then this is a special thing that you have to do using RexPro. Long story short, you have to iterate in RexPro for group count. And when you're in the Gremlin repression, like the actual one that I showed you guys earlier, it does that for you automatically. That is a badly documented feature in Titan that they need to fix. So I'm going to go ahead and forewarn you for that. But this will basically force the iteration to happen so the group count gets appended back to this hash map. And then I'm going to sort based on the number of users that have an occupation of type. So you saw earlier the average user age is 30 years. There were some 1-year-olds that apparently get on the computer and voted. So you did see that. Which means there's some really old people in there too. Not that being old's bad. Well, I just got a little older today. Oh no, being excavated from somebody is not something to congratulate about. So the distribution, right? Okay, so the same. Oh, she laughed. Anybody watch Big Bang Theory? Yeah, okay. That was one of the ones Sheldon said. So again, same function here. So all I did was query, okay, well, how many users are there? I told you there were 6,000 users earlier. How many of those, what are their occupation distribution? I'm just going to get the top 5. I don't care about all of them. The top 5 are college grad students. That makes kind of sense. A lot of college grad students have either drinking or going to movies, right, on dates. Hopefully dates. Or the other category, which probably are college and grad students. They just didn't want to fill it in. You have your executive managers, your educators, and your technicians, and the list goes on and on and on. There's a total of 21 occupations loaded, so I could load all 21. If I want to see Toy Story, so this one's hard-coded in there, that's that link. It goes straight to Toy Story. So okay, cool, Toy Story. It's right here. All I'm going to do is collect these iterations. So this is the actual script that ran internal to Mogwai. That you didn't see, but this is what runs internally. So it just collects these IDs that you passed here, so you could pass it a list or you could pass it a single one, and it'll collect them all and then send them back up. If I want to find out who rated Toy Story, I can do that really quickly. I'm going to pull the top 5, and so I'd pick it up. So here's their actual vertex ID. They're a female and they're 1. That's just the randomness of the cache. And then there's a 50-year-old here. So you pick them out pretty quickly. And again, here's the script, right? So I pull out the movie. I look inwards toward who rated the system. And then I filter based on stars. So I say, okay, well, they have to rate it with at least 3 stars that I care about. So users with 2 or less don't care about, or 3 or less don't care about. And then I limited the number. So what movies were rated by users who rated that movie with at least 3 stars? So now I'm looking at, okay, so people that rated that movie with 3 stars, what other movies did they look at? And then kind of group count them. So again, what I did was I looked at the movie right here, found the users, filtered out people that didn't have enough stars, and then I looked back out to the vertex and found, okay, that's the person, go back out to the vertex that they rated. Okay, go back in, figure out who filtered that again with at least this many stars. Look back inwards. Are you following me? So we're doing movie, right, to people, and then we're going back to movie with at least this many stars. So it's a double check, it's a cyclic check, because a user's going to rate other ones, but you make sure that you have at least that many stars. But there's a possibility that you have duplicates, right? So user A may have rated Pocahontas, but user B may also rated Pocahontas, but I don't want to see that twice. So I can deduplicate right on the graph. And it'll do that very efficiently. And so I deduplicate and return the top in. So I'll see that I didn't filter out Toy Story, if you notice that. So I still got Toy Story. You'd expect Toy Story to be there, at least in the total list. So Toy Story's in there. I got Pocahontas, I got Apollo 13, Star Wars, and Schindler's List, which is kind of funny. I guess a lot of people that watch Schindler's List watch Toy Story. So if I want to find out, okay, well, knowing by movies is cool. This whole concept of co-rating, right? So that's that same filtering, right? So I want to get movies that are co-rated, meaning they have the same stars, by the same people, the same query that you just saw. And I want to figure out how many votes did they get? How many people agreed with that rating? Or at least that rating plus, so 4 or plus. So I look at it and I'm like, okay, well, knowing Toy Story, how many users rated Toy Story with at least 3 stars? And how many of them were there? So of that, a lot of people, Star Wars, American Beauty, kind of funny, Matrix, and Raiders of the Lost Ark. So we got a lot of nerds. We probably got the engineer crowd here. Now, if I kept going through the list, you'd see the whole results, but there's a lot in there, so I won't load all of them. Okay, so I saw movies that are co-rated, but what about genre? Genre makes sense, right? I want to see action flicks, or I want to see children's movie flicks, because I have a 4-year-old daughter. I don't have a daughter, by the way. So what I'm going to do is I'm going to initialize a list, right, because I care about a set of movies that I care about. I'm going to run the same co-rated formula that you saw before. I'm going to filter out Toy Story right here. That's important because I don't really care about Toy Story. I already know I like Toy Story. Why would I want to know that Toy Story meets my criteria? And I'm going to retain all of those that have a genre that matches what I cared about. So I'm going to retain those. We'll go back 2 steps. And there's a special back method in Gremlin that allows basically me to go, okay, well, 1, 2. So that means I'm here. So I'm back at this filter out, which means I'm back at everything that didn't include Toy Story. And then I'm going to count them and iterate through them, and return the sorted values. And my bootstrap got crazy. So what I did is I filtered out, okay, of Toy Story, how many had a genre, at least in one of the several genres that Toy Story had. So Star Wars kind of missed the day, which is not true because it's actually in the results. American Beauty was in there. Back to the Future, that makes sense, right? Comedy. Toy Story, well, Toy Story 2, right? Because we care about Toy Story Run. So Toy Story 2 should be in there. Princess Bride, a children's flick. Groundhog Day. I actually never seen that movie, so I probably should go see it. And so those are my results. So very quickly, you can build these complex relationships. If you're noticing this, I can do these really, really complex things that would kind of be a really pain to do in Postgres. And very expensive computation. It's rather cheap to do in Graph. And so this is the mother of all queries, at least for this GMDB movie. So I want to get all co-rated movies that have all the exact same genres that Toy Story does. It's a children's movie, it's a comedy movie, and I can't remember what the other one was. So okay, here's my grand filter, right? So we do this correlation step. I'm going to filter it out. I'm going to find out who has the same set of movies or genres that I had before. And I'm going to group count them and then take it all in. So if you look at it, you get exactly what you'd expect. So if I was a child or a mother of a child or a father of a child that wanted to figure out more movies that would be good for my child to see, okay, Toy Story 2, seems reasonable, Bug's Life, Chicken Run, American Tail, Aladdin, those all make sense. And you can see how many people at least rated those with positive results. This one kind of bugs me because I loved Aladdin. So that's the basic concept of this application, and it shows you kind of the breadth that Graph can do in the complex relationships and the queries that can run inside the Graph. You don't have to build all that application glue out 18 different times or some function that you need throughout your application. So you're no longer loading this giant data in memory that's maybe a little bit compressed. You filtered out some of your results, so you don't have to do any further filter and processing. You can do it all in the Graph. All right, so let's go this way. Okay, so running close on time. I'm going to finish up this real quick. Gremlin Pi. I've actually showed a demo in the actual Mogwai Read the Docs page. I think I may have not pushed that up yet. But I show you how to do a global graph query, just like you'd use in the Gremlin REPL, and I show you how to actually use it with Mogwai to deserialize those results. And so instead of doing a random script and having to construct it yourself until Mogwai has that feature, I'll show you how to do things like that really, really simply. So technically, you could use Mogwai to do from other data sources if you wanted to, very, very easily, and it's very, very simple. There is plans to support vertex labeling and get rid of the element type, because that'll no longer make sense. TigerPop 3, so that's the whole coolness, streaming results. And then we actually do have plans to support migration and indexing support. So that's one of the things that is actively being worked on. Right now, if you want to do your indexing, you have to do it manually. So I highly recommend you have someone that knows what they're doing with database indexing. We have a guy named Ted for that, thank goodness. There is going to be support for import-export. It's not really designed for giant databases, right? It's really designed for hobby things that you want to kind of test out in development works. Integrate with additional metric collectors that you may be used to, like some of you may have heard of Segment.io or some other nifty features that you may want to include. It's very simple to build, and there's an actual documentation on how to build them. And then also build in caching support. So right now, if I did, person with ID 250 or movie with ID 256, every time I do movie ID 256, it actually queries the database, which is not ideal. You could probably do your own custom memcache or caching support built into your application. One of the things I want to build in is some sort of caching plugin that you could really easily use. And then, of course, be careful when using caching plugins. So, did I? Very well. Be careful, because a lot of it comes down to just like if you're using Cassandra backend or Hadoop, you have to have someone that knows how to tune Cassandra or Hadoop. When you're deploying Titan, it's actually really easy. It is recommended to have an architecture where you have a Cassandra node and a Titan node on the same machine. That way you don't have the communication lag overhead between the actual data store between Titan. So that is the recommended configuration from Titan, but it does scale very well.